Welcome, friends, for today's session on what, why, and how by Stats ST. The topic of our today's tutorial is correlation coefficient calculations using the deviation method. What is correlation? Correlation is the degree of association between two variables. It tells us the magnitude and direction of the relationship. Uh, Especially in statistics or in research, we sometimes want to understand, is there an underlying relationship between two or more variables? Example, I want to understand, does study hours have a material effect on grades, or does increase in promotion lead to increase in sales? This is the topic of our discussion. Now, using a statistical measure called as a correlation coefficient, I can calculate the magnitude and also the direction of the relationship between these two variables. Correlation is typically expressed as a correlation coefficient and a numerical value between -1 and 1. How did we get this number -1 and 1 is what I will explain when I am explaining the formula. Let me proceed. I've put up an example for you where I have given you 10 observations for 10 weeks pertaining to an organization where the sales range from 2,900 to 14,000. In terms of price, if you notice, the price varies from 1.05 up to 1.1. In terms of promotion, there are various promotional measures carried out by the company, and the spend on promotion has been depicted in the table. Now, a cursory glance for 10 observations would show you that as promotion tends to increase, sales also tend to increase. So, it is depicted by two blue arrows. So, if you see, if the promotion spend was 12.04, the sales corresponding was 3,400. A spend of 22 increased the sales to 3,900. Similarly, if I increase the promotion to 117, the sales went up to 14,000. So there is a positive relationship. As one entity increases, the same increases in the other variable. If you notice price and sales, because we have 10 observations, it's quite easy to understand that as price is increasing, the amount of sales is decreasing. So if you compare the price 1.1, the sales is 3,400, but as you drop the price, the sales have increased. Maybe intuitively, this might relate to the law of demand. As price increases, the quantity of demand increases. Now, as I mentioned, these two variables had a positive and a negative correlation. If I use a software to plot both the variables, so on the left hand side, I have price and sales. The observations are plotted as a dot. And if you see, if I pass a straight line through it, it is a downward sloping line. A downward sloping line indicates a negative relationship. As one quantity is increasing, the other is decreasing. So we can clearly identify that it's a negative correlation. On the right hand side, I've plotted sales versus promotion. And if you see that as promotion increases, the sales is also increasing. So if you look at the cursor, the line as promotion is increasing, the sales are also increasing. There could be some variables where the dots could be scattered around without any meaningful line to be passed. In case if I say I draw a line something like this, then it would show a zero correlation or no correlation. So typically, to summarize, we can have a positive correlation, we can have a negative correlation, and we can also have no correlation. Now moving forward, Why study correlation? It's an important topic of interest. One, by studying correlation, we can throw light on the related factors. Assuming I am collecting data on an organization, I could collect data on job satisfaction, I could collect on the age of the employees, I could also collect data on the number of family members. Now, if I use a correlation analysis, I could find out that job satisfaction, is it affected by the number of family members? Is it affected by the age? Is it affected by any other variable? If I can identify a particular relationship, then can I titrate it? Can I increase or decrease the independent variable? So it gives me some understanding that how variables are connected, especially in the field of business. Secondly, correlation can help in terms of prediction. So if I find that the number of family members has a negative correlation with job satisfaction, maybe I can predict that as the family members increase, I can expect that an employee might have a lower job satisfaction. That is what the data suggests. So it can be used for prediction. In terms of research and analysis, it is used in multiple fields like economics, marketing, finance. So it has varied use across domains in social sciences and pure sciences. In terms of decision making, especially in the finance domain, correlation analysis helps ascertain, should I spend more? Should I reduce? Will the stock price go up? So I've put an example of dividend versus price. So there is a dilemma for companies that if I increase the dividend, will the share price reduce? So these correlation analysis help a particular company to announce a particular type of dividend, the amount of dividend. In terms of modeling, we can go for higher levels of analysis like regression. Do check out my video on regression, where not only do we check correlation, but we also predict the change in the dependent variable. Also, time series. In terms of policy making, uh, it can help policymakers that does social media hours affect adolescent growth. So should there be intervention in terms of how many hours, or should there be a restriction as to how what should be the age in terms of adolescents when they can have access to social media? So it can also help policymakers, and especially for researchers, it helps in terms of hypothesis testing. A hypothesis is nothing but an conjecture or something that you want to test. So you have a conjecture or a hypothesis that variable X is connected to variable Y. You would like to collect data, and through correlation analysis, you would like to prove your hypothesis or disprove your hypothesis. So we have covered what is correlation, and we have also studied why study correlation. Now comes the important part of how to calculate correlation. Now, normally correlation coefficient is a number which signifies the strength and direction of a statistical relationship between two variables. So if you remember, I mentioned the range of correlation could be from -1 to +1. A +1 suggests a perfect positive correlation. That means if variable X is going up, variable Y is also going up in the same ratio. If the correlation coefficient is -1, it indicates a perfect negative correlation. Example, number of hours spent on social media will have a negative effect on grades. So it could have a perfect negative correlation, and anything between -1 to 0, 1 to 1 could signify a strong, moderate, or a weak correlation. A correlation coefficient 0 indicates no correlation. So the time of sunrise and sunset on the moon should have no effect on the grades of a particular student. So that would be an example of a no correlation. Normally, when we speak about correlation coefficient, we are speaking about Pearson's correlation coefficient, which was suggested by Pearson, Carl Pearson. It is denoted by the letter R, small r, And the formula to calculate R is put up on your screen, which is n summation dx dy minus summation dx summation dy upon some square root of n summation dx square minus summation dx the whole square. If you see, the term on the numerator is your covariance. Covariance is nothing but the variance of x into the variance of y divided by the standard deviation. Now, covariance will clearly tell you, or what is covariance? Basically, dx stands for x minus x bar, or it denotes the variation in the data from the mean. So, if the mean height of a student is 6, and if there are students who are 5, 6, then they are lower than the mean, and if there are students above 6 feet, then they are higher. So, it calculates the deviation from the mean, and when we divide it with the standard deviation, we are getting rid of the scale. So assuming I am comparing height, and um, height is measured in centimeters, whereas I'm looking at job satisfaction. So these are the two variables I'm looking in terms of correlation. Height is measured in centimeters, whereas job satisfaction could be not having a metric scale. So to get rid of the metric scale or any scale, we divide the numerator with the standard deviation of both x and of y. So we get a pure number like -1 up to 1. You can consider this similar to percentages. So if you see, percentages are never in terms of marks, centimeters, kgs, but it only signifies the strength. So this is the formula for correlation. Let's see if we can solve this using a pen and paper method. So I have two variables put up here, x, which has 10 observations, and the total is 460. So if I have to find the mean x bar, it would be 460 divided by 10, which is 46. If I take y, the observation given for y are 10 observations adding up to 40. So the average should be 40 divided by 10, which is 4. Now, as per our formula, we need to calculate dx. If you see here, x minus x bar. So if I take 46 as my mean, 30 minus 46 should add up to minus 16. 32 minus 46 should add up to minus 14. I would do this for individual x observations, and when I add them up, the sum total of dx would be 0. So if whenever you're using x bar, your sum of deviations would be 0. In some methods, when the x bar is a decimal, you can also use assume mean. So rather than using say 46, you can use 50, 48, 40, and you would still get the same answer. Similar operations we would conduct on dy, that is y minus y bar. In our case, y bar is 4, so 1 minus 4 is minus 3. If I can show you, 0 minus 4 is minus 4, 2 minus 4 is minus 2, 5 minus 4 is 1. So the sum total of dy also is 0. I take individual observations of dx and square them up, dx square. Similarly, I have dy square and dx into dy. So let's go ahead and calculate. So I denote the correlation coefficient with a small r. And in the numerator, I have n. N is the number of observations. So 10 multiplied by dx dy. The summation of dx dy is 230 minus summation dx is 0 multiplied by 0, which is dy. Now I divide by the standard deviation of x. So I take square root 10 multiplied by dx square, which is 1092, minus dx the whole square, which is a 0, multiplied by n again 10, and dy square is 64. Again dy the whole square is 0. If I solve this equation, in the numerator I should get 2300. In the denominator, 10 into 1092 would be 10920, and if I take the square root of that, it should add up to 330.45. And if I take 10 into 64, it would be 640, and a square root of 640 would be 25.29. So this is my denominator, 25.29. So if I go ahead and solve, I would get 2300, and a product of 330.45 into 25.29 adds up to 835.9. I go ahead and do the division, and the R value that I have got is 0.27. Now, how do I interpret this R value? As I mentioned to you, let me draw this here, -1 up to +1. This is my, so +1 and -1, and this denotes 0. So my 0.27 would lie somewhere here, which is 0.27. 0.5 denotes moderate positive relationship. So if I have to interpret my correlation coefficient, I would say a small positive correlation between X and Y. I hope the calculations were understood. Let me recap. To calculate the Pearson's correlation coefficient, we have the formula R is equal to N dx dy. Dx stands for deviations from the actual mean, X minus X bar, and dy stands for Y minus Y bar. Y bar is the arithmetic mean of Y. We have dx square and dy square. If I input all the values in the formula, I should be able to get my R value, which was 0.27. Now, can I use a software to calculate the same? So what I do, I go to Jamovi, I open a data file which is sales. This is the same data file for the 10 observations for sales, price, and promotion. And I wish to find out that is there a positive or a negative relationship between these three variables. So I want to do a simultaneous. If you look at the number of observations, these add up to 30. So it's quite cumbersome using the pen and paper method. So let's see if we can use the software. In Jamovi, specifically under regression, you have something called as correlation matrix. Once you open this, choose the variables that you want to correlate and find the correlates. I take all the three variables to the right hand side, and if you see in the output box, you should get a 3 by 3 matrix. A 3 by 3 matrix tells you what would be the relationship between. So if you take sales and sales, it shows no correlation because it would be a perfect correlation of 1. If I look at say sales and price, it shows minus 0.57. If you remember, correlation lies between -1, 0, and +1. A minus 0.5 shows a moderate negative relationship between sales and price. If I correlate sales and promotion, it shows 0.69, which is greater than zero point 0.5. So this is a strong positive correlation between sales and promotion. On the other side, if I look at price and promotion, it shows minus 0.6, which is a stronger negative correlation between price and promotion compared to sales and price. So this is how you can use a software to calculate correlation matrix and then report the values. I hope this session was useful to you. If you like my session, please go ahead and give a thumbs up or subscribe to my channel. Thank you.